choice and then 3 calculations. Let me go over the calculation questions. You'll notice that the time constant and the speed of light are listed at the top. So that is there. So multiple choice. Here's the calculation question. You have to put the right answer in the right spot. There should be no blanks when you're done. So you'll fill in your information from your question. Make sure you type it exactly as it appears. You have your constant. Then you have whatever you're solving for in this scenario, followed by what's the question asking you to find. What's your final answer? Units are not required, but sig fig matters. So if you round it correctly, it's wrong. That's one of the questions. And here's one of the fill in the blanks. Another fill in the blank. This one, students are missing this one, just put it in the right order. When you look at your 2 equations, you have C equals wavelength times frequency. You have E equals H times frequency. It has to go in that order. If this is the wavelength question, your C would go in the first box, your wavelength goes in the second box, your frequency goes in the last box. If you put them out of order, it's wrong. So make sure whatever you're doing when you're doing your answers, you round accordingly and put it in the right spot. The last one, it's very straightforward what I'm looking for. There should be no blanks, so you'll fill in your 3 answers and then round the right number of sig fig. Keep your scratch paper, throw it away, that's up to you. There will be a retake, but I have to go through and check all of your quizzes to make sure you get points. So that'll happen sometime today, and you have until Tuesday to retake it. When you finish this quiz, start taking the notes for today. You'll go to Canvas, copy the yellow. I will start that notes at about 1:35, 1:32, 1:33 or so. I'll leave this up because it doesn't stay up on some of the quizzes, so you have that info there. Good luck. Do not talk. Do not blink.
I get 30 minutes.
Any questions for me right now?
You're stupid.
When you round like the sig figs, you don't count the constants. That's,
No. Okay. Give me a second. Any other questions?
I have trouble with your computer.
It has to be in the formula, yes. It's still loading.
I'm cold.
Yeah.
What?
Okay. If you want, you can. You can sit there. You can sit there. Yeah. If you're unsure about the placement, let me know. Yes. So whatever you draw for you.
What? Don't stop. You just doused you. Oh. I give up. I guess.
And again, units are not required.
Oh.
You want to include them, you can, but they're not required.
Well, I get points wrong if I put the wrong units.
That, yes.
Just don't put them. All right. It doesn't matter.
On your calculator.
What if I don't know how to put it in my calculator? It's so stupid. Before she gets me in trouble.
No. Yeah.
I can't copy you. You have a different set of questions.
That's recorded. What is pricing? That's the last.
B. Shut up.
Yes, that's the last. Oh, yeah.
I'm gonna kick you. I'm a backflip drop kick you.
Was it tomorrow?
You did? Someone did. I started with something. I smell like something going on me. Oopsies. What do you like? $2 million. What the? Such a fat. Oh my god, I just said that on live. I hate that. Okay.
Yep. Yes. No.
I don't know how to do this. Oh, I know how to do this. How do we put times? You're dumb. Do we just put an X? Space X. Space X. What's V? I don't know how to do this.
I will check each one of your results, so if something gets marked wrong, I'm gonna double check that it is not been marked incorrect.
Oh.
So I work on that.
Do this. Bro. You have to tell her.
Or plug it in.
Hmm?
Or plug it in.
Okay. That's all I'm doing. I'll just. And now you're not gonna,
Resume.
now you're not gonna
So
able
let's
to.
resume.
Okay. I don't know. What? Shut up the fuck up. You see the rounding is correct. Stupid. Oh, what? I'm not doing it. Anyways, back to the live stream. Look at this stupid. Tip, you bring a hoodie. Right here. Right here. Your hands are cold.
Do not start talking. Copy your notes.
Shut up, Owen.
You get a retake. Hello?
Fuck no.
Alright, so let's switch gears. Some good news. There's no calculations in the second part of this unit. So that can be good or bad.
Fuck.
So we're going to talk about how the arrangements of the electrons lead
Oh my
to
god, you're so bad.
the properties of these elements based on what's on the periodic table. So we copied in yellow. So let's get started. So the arrangement of electrons within the atoms has some things you gotta follow. We're gonna talk about electron configuration starting on Monday. We're gonna do the background today and tomorrow. So this is gonna be how the electrons are arranged in the different energy levels.
Got it, finally. Nice. Now we got that on stream. Oh my god. Thank you for the universe. Oh my god.
So
I can feed my homeless
in
mom.
chemistry, everything is trying to use the least amount of energy. And being stable is what uses the least amount of energy. So what is happening in atoms is their interactions between their nucleus and the electrons in the atom is looking for the most stable relationship. That leads to the electron configuration that we're talking about. Now the picture you see there in a perfect world would be how this lays out. This is called the planetary model. Unfortunately, it's great for 2D representation, but it's actually not what happens. Bohr was going for the old Bohr from the atomic theory foldable. And what it does is it visually represents what's happening with the electrons inside of an atom. So the dark sphere in the middle is the nucleus containing the protons and neutrons, three elements, iron, which is 26 electrons. And then each of these rings corresponds to an energy level as we move away from the nucleus. So you've got the first energy level, the red one, is 2 electrons. It's all can hold. It is full. So then we move out to the blue ring, which is the second energy level, containing up to 8 electrons. We'll talk about why in a second. Once that's full,
No,
we move
why?
to the third, which is going to be the third energy level. Now it's not quite full, and we'll learn why on Monday.
No.
But right now there are 14 electrons in that
You know what
third
I'm gonna
energy
do?
level. And then the last but not least, the
Jacking
orange
me.
is the fourth energy level containing 2 electrons. So if I add all those
Jacking me
up,
off.
it is 26 electrons. Now, like I said, this is not what is actually happening. There's some 3D aspect. This is obviously a 2D scenario. So the quantum mechanical model is what we are at in our knowledge of atoms and electrons. It took 100 years to get to this point. That being said, it might, as we continue to get more information, it could change, but probably not. So what it
You're
is,
left.
you have a
I'm
picture of an
left-handed.
atom. This is actually a hydrogen atom. The little red dot in the middle is the nucleus containing its proton. And then somewhere in that blue sphere is its 1 electron. Sipping around doing its thing. We're going to help narrow down where that electron is today.
Bless you. Stop getting my right arm like I'm right arm. I'm not right handed. You stupid piece of bacon.
Now this applies to any and every atom. They're all going to have the same pattern, but where the electrons are is a little bit different. So, we need 3 things for the arrangement of electrons. We're going to start out at the farthest or the biggest, the energy level. So the energy level was the rings I showed you on that 2D picture.
Ow, my head.
The energy level is written 3 different ways. So let me tell you what they are so you don't become confused to see them in a different form. The principal quantum number. That is one way to say it. Principal quantum number 3. I'm referring to the third energy level. I say energy level. That one's extremely straightforward. Or I say lowercase n equals. Lowercase n equals 4. That's the fourth energy level. So again, those are 3 aspects that you can see for the energy level. So this is this is kind of the biggest part of the atom in terms of where the electrons are. So then we drift down into a little more specific area because electrons are kind of zipping around, so we only have a chance of determining the probability of where they're at, not actual locations. So after the energy level, we delve into what we call the sublevels. This is going to narrow down where we can find our electron. It's a region that fits within the energy level.
Bless you. Are you still on the first slide?
So we've narrowed down
Stop.
where our
I'm black.
electrons might be. We can go a little bit farther. So within the sublevel, we can really narrow down the location and have the highest probability of finding our electrons within the atomic orbitals. So this is where we're going to have a chance of finding our electrons. So you have a city. In that city, there are streets. On those streets, there are houses where people stay. So how do we compare that to the atom? Your city is the same as your energy level. In the city, you have streets. In the energy level, you have sublevels. On the sublevel that hold people, in the sublevel, you have orbitals that house your electrons.
Shut off my computer.
So that's kind of the scenario where you can kind of rationalize what's happening. So energy level, sublevel, atomic orbitals.
Let's see. No.